Thank God it's Friday. Thank God it's Friday. TGIF, TGIF. Right here at Paulstutorialservices.com Facebook page. Paulstutorialservices.com Facebook page. It's Friday and we are happy. It's Friday and we are happy. We thank God for Friday. Hope you're going to have, I wish you a good weekend. I wish you a good weekend and I hope you are having a good week so far. I hope you're having a good week so far. Let us finish strong this week. Let us see how we're going to finish strong this week. And today in Maths Lab we are going to learn about natural numbers. We are going to learn about whole numbers, integers, rational numbers. We are going to identify what are the rational numbers. We are going to also look at irrational numbers and real numbers, irrational numbers and real numbers right here at Paulstutorialservices.com. Please remember to continue following my page, Facebook page, Paulstutorialservices.com. Continue to support this page, this service coming to you every day of the week, coming to you at least Monday, Wednesday and Friday, when we look at our Maths Lab and Science Lab, Monday, Wednesdays and Fridays. Anytime you see a prompt on Facebook Live, please remember to join us. Anytime you see a prompt on Facebook Live, please remember to join us at Paulstutorialservices.com Facebook page. Also, we are streaming on YouTube. Got a YouTube channel. You can visit at Paul Yongo. The handle is Paul Yongo at 10009, I believe. And I'll be sure to make it more certain for you later on. I'll be sure to make it more certain for you later on. But at least you can find us on YouTube page, YouTube channel, where I post some short videos and also long videos, short videos and also long videos. Continue to share my live streams, continue to share my videos, continue to invite your friends, continue to invite your students who are still going through academics, your students who are still going through academics. Register for tuition as always. Register for tuition. We also offer one-on-one tuition. We also offer one-on-one tuition. And we also offer group virtual online tutorial services. Group virtual online tutorial services. All this you can give us, contact us through completing a submission form. You can contact us through submitting a submission form. You can apply through our Facebook page, Paulstutorialservices.com. Also through our website. We've got a website running, Pauls101tutorialservices.com. Visit the website and submit a form. Visit our website and complete a submission form where you can give us your detail, including email and contact numbers, so that we can reach you and continue with the tuition services at affordable 1 hour rate. Continue also to support this service. Is a community service, is a global service to the community. You can give a gift or you can just support out of your kindness. You can give a gift or you can just support out of your kindness. Also, you can enroll for tuition. You can enroll for tuition at affordable 1 hour rate right here at Paulstutorialservices.com, where we make learning fun and enjoyable. Paulstutorialservices.com, where we make learning fun and enjoyable. Please stay cool out there. Stay cool right there. The weather is getting a bit hotter over here. The heat index is at 111 right now. The heat index is at 11 and at 111 right now. Please, if you are in the US right now, drink a lot of water and stay cool. Stick with me as we carry on. Stick with me as we carry on. Let me turn the AC on right now, even as I talk of the temperature. So our first example on the board, we are being asked to list all numbers from the given set that are natural numbers, whole numbers, integers, rational, irrational numbers, and real numbers. So we got the number, we start with the -7, and then we go -4/5, and then we got the number 0, and then we have 0.1, then we have the square root of 7, we have 7 under the root, 7 under the root, and then we have 3.8, and then we have 64 under the root, 64 under the root. So now we are being asked to identify the natural numbers. So what is natural numbers? When we look at it carefully, we see that 64 under the root is 64. The root of 64 is a natural number that we are used to seeing a number like that. So 64 is a natural number. 64 is a natural number, and the way to find out is that 64 is the square root of 64. Has a multiplier of 8. 64 has a multiplier of 8. Then that means that any time we multiply 8, that means that anytime we multiply 8 by itself, we get 64. Anytime we multiply 8 twice, when we multiply 8 twice, then we get 64. So now 64 is a natural number. 64 is a natural number, because now you can say that the square root of 64 is 8. Just like I said earlier, the square root of 64 is 8. So we're going to say that the square root of 64 is 8. So the square root of 64 is 8, and then 8 multiplied by itself is 64. So the set of all numbers consists of natural numbers and 0. So we only have, this only gives us 64 as a natural number, and that means that the square root of 64 is equals to 8, okay? And 8 multiplied, 8 is a multiplier, okay? 8 is a multiplier, okay? 8 now is a multiplier of 64. So now like that so now we have like 8 multiplied by itself, okay? 8 multiplied by itself is 64. 8 multiplied by itself is 64. And so that means that 64 naturally comes. 64 is a natural number. 64 in that given set, 64 is a natural number. In that given set, 64 is a natural number. So the general term is the set of now that is the natural number. Now for the whole number. So now we are done with the natural numbers. So let us look for the whole numbers. And the description we have is that the set of whole numbers consists of natural numbers and zero. So if you want to know whether a number is a whole number, and we're going to say that it has to consist of a natural number and a zero. So like in this case now, we have the set, we have the root of 7. We have the root of 7, okay? So the root of 7. So now we find that 7 is a whole number. 7 is a whole number. And remember the set of whole numbers consists of numbers and a zero. They consist of natural numbers. The set of whole numbers consists of natural numbers and zero. So we can say that the roots of 7 and 0 are natural numbers. The root of 7 and 0 are natural numbers. So now, they are whole numbers. So now we have at least 3 whole numbers. So now we have the square root of 7, 0, and 64. So 64 is both natural as well as whole numbers. The square root of 64 is both natural as well as whole numbers. So these ones right here are whole numbers. This one right here are whole numbers. These ones right here are whole numbers. These ones right here are whole numbers. So now we already know we got at least, we have identified our natural numbers, and we have also identified our whole numbers. So now let us see if we can identify what are our integers, if we can identify what are our integers, So the set of integers consists of natural numbers and the negative or the natural numbers. So integers consist of natural numbers, the numbers with negative or whole numbers. The numbers with negatives or whole numbers. So now they consist of natural numbers and the negative or the natural numbers. So the natural numbers. So now, so any number that is that has a negative right here. So you can see now we have negative 7, and we have negative 4 over 5, and then now we have we have the natural numbers. Now we have the natural numbers. So in this case, there's also a 0. Let me see. There's also a 0 in there, right? So now 0 also is a natural number. So now 0, because you can multiply 0 by itself, and also you can divide it by itself. So it's an integer. So it is an integer. So now when I look at 64 is the square root of 64 serves both cases, because it's natural. As much as it's a whole number, it's also a natural number. So now, so long as it's a natural number, and it can also act as an integer, then it falls under this set. It falls under the category of 64. It falls under the category of 64. So now it falls under the category of integer. So the elements, sets that are integers. So now the element sets of integers, in this case we have we have negative 7, we have negative 4, we have 0, and then negative, and then the square root of 64. There's the square root of 64. Okay. So actually, what we do have is this. Let's take out this fraction because this fraction looks irrational. The negative 4 over 5 is irrational. So the only numbers that are integers in this case are negative 7, then 0, and the root of 64. Negative 7, 0, and the root of 64 are our integers. The root of 64 are our integers. Now that leaves us with irrational numbers. Let's make sure. Now that leaves us with rational numbers. That leaves us with rational numbers, and so the set of rational numbers is the set of all numbers that can be expressed in the form of A over B. So now the set of rational numbers is a set of all numbers that can be the set of negative numbers that can be expressed in the form of A over B. So now that means that if it is a negative number and it's in the form of a fraction, and also can be expressed in the form of A over B, which means it's a fraction where and A and B are integers, and B is not equal to 0. So the B is not equal to 0. So now you see, like, this negative 4 is our A, and this 5 is our B. So you can see that our B, which is 5, is not equal to 0. Our B, which is 5, is not equal to 0, and our A and B is our integer. So now this let us find out what our rational numbers. Remember this one here, we noted that these numbers here are our integers. These three numbers here are our integers. So now for our rational numbers, we have because negative 7 is as a negative, okay? So now negative 7 is a negative, so it makes it rational, or it can also be written as negative 7. It can also be written as negative 7 over, which is equals to 1 over, which is equals to negative 7. Is equals to negative 7 over 1. So anytime you see numbers like this, that is completely rational. Anytime you see numbers like that, written like that, is completely rational. It's rational to have a number like that. So also when you see negative 4 over 5, when you see negative 4 over 5, negative 4 over 5 is also a rational number. Negative 4 over 5 is also a rational number. Likewise, when you see 0, zero is also a rational number. 0 right there is also a rational number. 0 right there is also a rational number. But then now it can also be written as 0 over 1. Okay, this 0 is standing alone, so it's 0 over 1. So now, so it can be written as 0 is equals to 0 over 1. Okay, 0 is equals to 0 over 1. That's another way of writing 0 as 0 over 1. So that makes it a rational number. So now we do have the square root of 7. So we have the square root of 7. So we have the square root of 7 right here. The square root of 7, and also and then we have 0.1 somewhere. We have 0.1 and 3.0. So we have 0.1 and then 3.8, sorry, 3.8. All these numbers right here are rational numbers. All these numbers right here are rational numbers. So now let us see what are our, looks like, so now all these are rational numbers, and they are also real numbers. So rational numbers and also real numbers. So now that's all we got for the set of questions. You can see that all these numbers are rational numbers, and all these numbers are considered rational numbers, and they are also, I don't see any rational number right here. So we have real numbers. We have real numbers. So we have rational numbers, which is the square root of 64, which is 8. That's a real number. So it's both natural and real. It's both natural and real. And then we got negative 7 as an integer. Okay, we got negative 7 as an integer right here. We also have 0 and a square root of 64 as a natural number. So now, we have, I try to look to see if we have any rational numbers, but I don't see. So all we have right here are natural numbers, whole numbers, and real numbers. So we have natural numbers, whole numbers, integers, and real numbers. Natural numbers, whole numbers, integers, and real numbers. So it's good to know. We really need to know that before we go to the evaluation part of our maths lab today. It's good to know that before we do some evaluation and simplifying. Before we do some evaluation and simplifying. So let me erase the board and we do more examples as we carry on this Friday maths lab. Please continue to like and sharing. Continue sharing today's tutorial with your friends and with your peers. Continue to click the follow button at Paulstutorialservices.com. Continue to click the follow button at Paulstutorialservices.com, because we really need those we need those numbers. We need those numbers. We are moving up slowly but steady. We are moving up slowly but steady. We need at least we need to reach a target of at least 500 followers, and you can help us get that target. You can help us get that target by simply sharing the tutorials, by inviting your friends to like this page, to follow this tutorial at Paulstutorialservices.com so that we reach our target. We are close to 280 members right now, so we need the remaining 200 and something numbers of followers, over 220 or something like that number of followers. So help us get those followers so we can move on. And God will bless you. So let us simplify some. Let us simplify. Okay. Let us simplify. So we have -5 raised to the power of -2. Okay. So to simplify that, remember, any number like this, there's a coefficient of 1. Remember, any number that has a negative has a coefficient of 1. It also has a coefficient of 1. And if that number is negative, its coefficient would also be considered negative. So in this case, we have to multiply. By -1. So we're going to multiply -1, and so now we're going to multiply by -1 by 5 raised to the power of 2, by 5 raised to the power of by 5 right here raised to the power of -2 right here. So this equals to the coefficient of 1, -1, multiplied by 5 raised to the power of 2. And when we do that, we get, now we get rid of these negatives. So now these negatives are gone. So now what we have down here is 5 raised to the power of 2. 5 raised to the power of 2. And now that equals to the other side as -1 in bracket. So now this -1, we're going to put a bracket on it. And now -1, we're going to put a bracket on it. And then we're going to multiply by 1. We're going to multiply by 1 over 5 over, by 1 over 5. To the power of 2, by 1 over 5 to the power of 2. Okay, actually, let me correct that. So we're going to multiply. We're going to multiply. So this will be -1. We multiply by 5. And so now, and then now this takes care of the -2. So now the negative is gone. So now it becomes 1 over 5 squared. So now it becomes 1 over 5 squared. And then now that gives us, when we do that, that gives us now -5 squared. So now that gives us, so when you do that, that gives us, when you do that, that gives us -5, because -1 multiplied by 5, okay? That gives us -1 multiply, that gives us -1 multiplied by 5 raised to the power of 2 by 5, -1 multiplied by 5 raised to the power of 2 right here. -1 multiplied by 5 raised to the power of 2. So -1 by 5 is -5. But then you raise it to the power of 2 up there, and then now down here we have 25. Down here we have 25, because now is 5 multiplied by 2. Now we have 25 because of 5 multiplied by 2. So that equals to, that now equals to negative 1 and 5 over 2, which we already got right here. That's now equals to negative 1 and 5, negative 1 and 5 squared, negative 1 over 5 squared, which you already got here. And so now that comes down. So now we're going to say that negative 5 to raised to the power of negative 2 is equals to 5. It's equals to negative 5 squared over 25 is equals to negative 5 is equals to negative 5 squared over negative 5 squared raised to the power of negative 2 is now going to be negative 1 over 25. It's now going to be negative 1 over 25, and this is why, because 5 squared is negative 5 squared gives us negative 25, okay? And then now, when you divide that by 25, which we have down here, when we divide that by 25, which we have down here, then we're going to have, we're going to say that that 5 goes, that 25 goes here 1, and then 25 goes here negative 1 over 25. So now you can see, so now it goes, and then now you have to put it in bracket because everything is on bracket, so we have to put our parentheses like that. So now we have to put our parentheses like that. So now our final answer is negative 1 over 25. Negative 1 over 25 is our final answer. That's how we simplify it. Hope you followed it. That's how we simplify a number like this. So if you're given an irrational number, so we have to simplify it so we make it rational. So when you're given an irrational number, we have to simplify it so we make it rational. So now you can see how we broke it down. We took care of the negative so that we remain with the 5 squared, and then that is equals to negative 1 multiplied by 1 over 5 squared, okay? So now when we do that, then we remain with negative 5 raised to the power of negative 2 right there, you see? And then now that is equals to 5 squared divided by 25, which gave us negative 1 over 25 is our final answer. Negative 1 over 25 is our final answer. So now let us see if we can write using a positive exponent without evaluating. So now let us see if we can rewrite it using a positive exponent without evaluating. So let's have a different number right now, a different example right now. So our example 3 for today is to write it with a positive exponent. We're going to write it with a positive exponent without evaluating. We're going to write it with a positive exponent without, we are going to write using positive exponent without evaluating. And now we've been given 7 raised to the power of negative 2. 7 raised to the power of negative 2. And we are being asked to write using positive exponent without evaluating. So if we are not going to evaluate and we're just going to make it positive. So now 7 or our 7 raised to the power of negative 2. So now to make it positive, so now that means we are doing away with the negative sign. To make it positive, it means we are doing away with the negative sign. We are doing away with the negative sign. So if we do away with the negative sign, remember there are always a coefficient of 1. There's always a coefficient of 1 anytime you see a negative sign right there. So now that means that there is 1 over this number. So now that means it's 1 over 7, okay? So now that means it is 1 over 7 raised to the power of 2, raised to the power of 2. So now that is our final answer. So 1 over 7 raised to the power of 2 becomes our final answer. So you can see that using a positive exponent without evaluating is simple. It's more simpler than when you have been given the one with a negative, and when you are being asked to simplify. So if you can find that you only takes care, you do away with the negative side, you make everything positive, and you remain with the 7 squared. So it's 1 over 7 squared. So it's 1 over 7 squared. So we've simplified it without evaluating it further. We've simplified it without evaluating further. What about if we are given negative 5 raised to negative 6? So if we are given negative 5 raised to the power of negative 6, how are we going to handle that? So how are we going to handle that? Negative 5 raised to the power of negative 6. So that means that, remember, the key thing to note is that there is always a negative 1 beside the number given. So we are going to multiply it by negative 1. So we are going to apply a negative 1. We are going to apply a negative 1. We are going to apply a negative 1. Okay, so we are going to apply a negative 1, and we are going to multiply it by 5 raised to the power. So we are going to have negative 1 multiplied by 5 raised to the power of 2 somewhere, by 5 raised to the power of negative 2, okay? By 5, remember to put your 5 in bracket because that is a sign of multiplication. Raised to the power of 2, raised to the power of 2, and then now that means now that we are going to have raised to the power of 2, okay? And that means when we do, that is like 5 minus 2 give us 3, and then now 3 multiplied by 3 give us 3 multiplied by negative 2 give us negative 6 right there. In case you are wondering, why do we have the exponent of negative 2 up there? Why do we have the exponent of negative 2 up there? So now what remains is that we have 5 squared. So now we have 5 5 squared is equals to, now we have 5 squared is equals to negative 5. Is equals to negative 5 to the power of negative 2, which is equals to negative 1. So now, we have 5 squared, which is equals to negative 1, right? So negative 1, remember, there's always this negative 1 here, so it equals to the power of negative 1, put in the bracket, multiply by 1 over 5 squared. So now there's always 1 here. 5 times negative 1 times 5, right? So multiply by 1 over 5 squared. 1 over 5 squared. Let me make sure I got it right. So it's multiplied by 1 over 5 squared right here. So now we've taken care of the negative. So now we've taken care of the negative 2 up there, and we brought it down here. So now, this 5 squared is equals to negative 1 multiplied by 1 over 5 squared. So this 5 squared is equals to negative 1 multiplied by 1 over 5. So now that gives us we're going to have negative 5. So now that means that negative 5 raised to the power of negative 2, right? Negative 5, this negative 5 raised to the power of negative 2 up there. Negative 5 raised to the power of negative 2 up there gives us this negative times this negative 1 times 1 right here. So it's going to give us negative 1 over 5 squared, which is 25. So it's going to give us negative 1 over 5 squared, which is 25. And so now our answer is, our answer is 1 over 25 negative. So now our answer is 1 over 25 negative. 1 over 25 negative. 1 over 25 negative is our answer. 1 over 25 negative. Or you can say negative 1 over 25, negative 1 over 25. So now the key thing is to understand how to break it down, because you can see we were given negative 5 raised to the power of negative 6, but you see now we had to simplify it further to mean that this one is equals to negative 1 multiplied by 5 in parentheses raised to the exponent of negative 2, raised to the exponent of negative 2, so that when you simplify it, we get 3, so, and then you multiply by 2 to get negative 6 up there. So now that means 5 squared, so now we have this 5, when it crosses over, it takes away the negative. So now we have 5 squared, which is equals to this negative 1 multiplied by 1 over 5 squared, okay? Now that gives us negative 2. That gives us negative 2, because so that gives us negative 2, because now we have 5 multiplied by negative 1, it gives us negative 5 right here, raised to the power of 2 multiplied by negative 1. So you can see how we got negative 5 raised to the exponent of negative 2. And then that's now is equals to this negative 1 by multiplied by 1 gives us negative 1 over 5 squared, which is 25, okay? Over 5 squared, which is 25. And now that becomes our answer as negative 1 over, becomes our answer as negative 1 over 25, negative 1 over 25 is our final answer. So that's how we simplified it. But now we simplified it. So now looks like we simplified it already. We simplified it already. Okay. So now we simplified it already right there. So now let us see if you are given a negative 5 raised to the power of negative 6. Yeah. I guess that was another version of doing it. We can look at a different version of doing this. Yeah. I know I got it mixed up somewhere, but it's okay. So now let's move on and look at another example. We are going to do another example without evaluating. Yeah, that's weird how it happened, but so we have 8 raised to the power. So now you have given 8 raised to the power of negative 2. Okay, this is when it's simplified it. Remember, we are simplifying without evaluating it further, so it becomes 1 over 8 squared. So without evaluating, okay. So when we do not evaluate, it becomes like that. Okay, when we don't evaluate, but then if we evaluate, then 1 over 8 squared. So now when we evaluate this, 1 over 8 squared, then it becomes 1 over 64. Then it becomes 1 over 64 because now we are evaluating it further. We want so when evaluated, then this is the answer right here. So without evaluating, 8 raised to the power of negative 2 it becomes 1 over 8 squared without evaluating. But when you evaluate it further, then 1 over 8 squared becomes 1 over 64. 1 over 8 squared becomes 1 over 64. So now you can be given let me erase the board again. So let me erase the board again. Okay. And we'll have to revisit one example, but let's carry on for now. So rewrite, you can be given 6 raised to the power of 3. 6 raised to the power of negative 3. And we are being asked rewrite expression without using negative exponents. So now we rewrite it, okay, rewrite expression. Rewrite the expression without using negative variables, okay? So we are going to rewrite it without using the negative variable, and we assume that all variables without using the negative exponent, without using the negative exponent. So we are not going to use the negative 3 right there. And we are going to assume that all variables are positive without using the negative exponents, and then assume that the instructions are that assume that all variables are positive, okay? That all variables are assume that all variables assume that all variables represent non-zero numbers. So all variables represent okay. All variables represent non-zero numbers. So we are assuming that all variables represent non-zero. All variables represent non-zero numbers. All variables represent non-zero numbers. So how do we do that? So we have 6x raised to the power of negative 3. So now we're going to say that 6x raised to the power of negative 3 is the same as 6 multiply, okay, so this is the same as 6 multiplied by a 1 over 6, okay? It's the same as 6 it's the same as 6 multiplied by 1 over, it's the same as 6, okay, multiply, you can put a sign, let me put a dot to avoid confusion. So 6 multiplied by 1 over x, so this is the same as 6 multiplied by 1 over x. So this x has a 1 over it, this x has a 1 over it. And then, so it's multiplied by 1 is the same as 6 multiplied by 1 over x, and then that x is cubed. That x is cubed. So now when we do that, then we have 6 times 1, which gives us 6 over x cubed. When we do that, then we have 6 times 1, which gives us 6 over x cubed. So now this one right here is our final answer. This one right there is our final answer. And that means that all that we've done is to rewrite the expression without using negative exponents. You can see we have avoided using the negative sign. So we have rewritten the expression without using the negative exponents, and we have assumed that all variables represent non-zero numbers. All variables represent non-zero number. So this x is a non-zero number. This x is a non-zero number. So that's how we do that. That's how we do that. Now let's look at could be our last one before we revisit something. Let's look at our last one before we revisit something. And then tomorrow we will carry on. Tomorrow we will carry on. Continue to like and follow. Give us positive feedback. Tell us what you think of today's tutorial. Tell us what you think of today's lab work. Today's maths lab. And we've been looking at real natural numbers, real numbers, rational numbers, and also what other numbers? Integers, and also we also will look at irrational numbers. So let us continue simplifying. We've been simplifying numbers without evaluating, and also we've been simplifying numbers using evaluation methods. We're using evaluation methods. Let us know what you think of today's math lab. Let us know what you think of today's math lab, and continue to follow, continue to share this tutorial to other friends of yours. Continue to share and follow these tutorials so that other people may be blessed. So now let us simplify by writing expression using only positive numbers. Simplify by writing expressions. So simplify by writing expressions. Simplify by writing expressions. Simplify by writing expressions using only positive exponents. Using only positive exponents. So let us see how we're going to do that. We are writing expressions using only positive exponents. So now we've been given numbers right here. We've been given negative 8t raised to the power of negative 2. So we've been given negative 8t raised to the power of negative 2. And the instruction is we have to write the expressions using only positive exponents. So now that means that so we are going to start with t. We are going to start with t because now 8 has a negative, so we are not going to start with a number that has negative sign on it, because the instruction is using only positive exponents. So now this t is considered positive, and it has the exponent of negative 2. So we're going to say that t raised to the power of negative 2, we're going to make it positive. T raised to the power of negative 2 right there is equal to, so now this t right here, remember there's always 1 over t squared. So now it's equals to t over now it's going to be t over now it's going to be 1 over t squared. Now it is going to be 1 over t squared. Now t raised to the power of negative 2 is going to be 1 over t squared. It's going to be 1 over t squared. So now that means that now we have 8t. So now we have our negative 8t, raising it to the power of so now we have our negative 8t raising to the power of negative 2 right there. And then now is that equals to negative 8, okay? So now that is equals to negative 8. I don't know if there's a t right there. So now that is equals to, now we've taken away, we're doing away with t now. We're doing away, because we already have t squared now. We already have t squared, so now we're doing away with the t in the 8. We're doing away with the t in the 8. So now we have our negative 8t is going to be negative 8 multiplied by 1 over t squared. So now our negative 8 is going to be multiplied by 1 over t squared. And now what do we get when we do that? What do we get when we do that? What we get when we do that is we end up with so now we end up with our negative 8 multiplied by 1 over t. So now we have our negative 8 multiplied by 1 over t squared, okay? Negative 8 multiplied by 1 over t squared, and that now gives us, so when we do that, so it gives us negative 8 multiplied by 1, so it gives us negative 8 over t squared. So when we do that, then it gives us negative 8 over t squared, and now, so now that is to say that negative 8t, that is to say that negative 8t right here, raised to the power of negative 2, okay? So now that is to say that negative 8t raised to the power of negative 2 is equals to negative 8 over t squared. Let me double check that. Is equals to negative 8 over t squared, right? So it's equals to negative 8 over t squared. So it's equals to negative 8 over t squared, negative 8 over t squared, all right? So negative 8t raised to the power of negative 2 is equals to negative 8 over t squared. So now this right here, this number right here is equals to negative 8t over negative 8 over t squared. So look how we did it. So now we end up with only one negative on this side. Now we have rewritten the expression, and we have now remained up with the expression has been rewritten, and now we have negative 8 on the top. Now we have negative 8 at the top, and then at the bottom we have t squared. At the bottom we have t squared. So that's how we rewrite it. That's how we rewrite the expression. We simplify by rewriting the expression using positive exponents. So we rewrite the expression using positive exponents. So we've made it more positive than it was earlier, because you can see we had 2 negatives, but now we ended up with only 1 negative, and that negative is at the top of what t squared is at the top of our variable. So it is negative 8 over t squared, right here at Paulstutorialservices.com, Paulstutorialservices.com, where we make learning fun and enjoyable, where we make learning fun and enjoyable. I want us to revisit one example that we did earlier. My version kind of made more sense to me, but let us also see another example. I had you could see how we did the maths on the example earlier, and it worked just fine. We did some maths on the example earlier, and it worked just fine, and it makes me feel good about how we did it. It makes me feel good about how we did it. But let us look at another version according to the book. Let us look at another version according to the book. So negative 5 raised to the power, negative 5 raised to the power of negative 6. We want to get it according to the book. So this is this equals to, it translates to negative 1 raised to negative 1 multiplied by 5. So this translates into negative 1 multiplied by 5, okay? And then remember we have a bracket in there. So negative 1 raised to the power of negative 1 raised to the power negative 1 multiplied by 5 raised to the power of negative 2. Okay, so equals to negative 1 in bracket. It's equals to negative 1 multiplied by 5 in bracket and raised to the power of negative 2. And then now that means now we end up with when we do all that, then we end up with a 5 squared. So now we're looking at this side. So when we do that, so we end up with a 1, So you remember when a negative crosses there, it becomes positive. So now we have 1 times 5 will give us 5. And then that 5, because that one has crossed over, so we end up with that 5 squared. So now it's 5 squared, okay? So now it is 5 squared, which gives us negative 5 squared, which gives us negative 5 squared, okay? So now, which gives us negative 5, which gives us negative 5 raised to the power of negative 2. So now this 5 squared gives us negative 5 raised to the power of negative 2, which also translates to negative 1 in bracket. Remember we are multiplying with the negative 1, so negative 1 in bracket, which multiplied by 1 over 5 squared, okay? 1 over 5 squared, 1 over 5, not the square sign is inside the bracket. So it's 1 over 5 squared inside the bracket. So you remember we are multiplying, so you put a dot there to show that we are multiplying. Put a dot there to show that we are multiplying. So it's 1 over 5 squared over 5 squared. So now when we do that, so now remember when we do this, this negative cancels with this negative. So now we have 5 squared is 25. So now we have 5 squared right here, which is 25. So now we have 5 squared right there, which is 25. So now we have 25 somewhere. Now we have 25 somewhere. So now we are simplifying it. Now to simplify it, now we are going to say that negative 5. So now this negative 5. So now we are going to say that negative 5, okay? raised to the power of negative 2 is equals to 25, okay, is equals to 25, which is equals to 1 over 25, is equals to 1 over 25. You can see, but let me erase it so I make it more visible to avoid confusion, okay? So let me write it clearly for you. So remember we have this 5 squared right here. This 5 squared right here is equals to, is the same as saying negative 5 squared. So before I put all this thing right here, so it's the same as saying negative 5, the same as saying negative 5 raised to the power of negative 2. So this right here is the same as saying negative 5 raised to the power of negative 2. And now remember that we said that negative 5 raised to the power of negative 2. This negative 5 raised to the power of negative 2 is equals to 25. Is equals to 25, okay? Negative 5 raised to the power, negative 5 raised to the power of negative 2 is equals to 25. Is equals to 25. And now, so now our final answer now, remember our final answer therefore becomes, negative 1, because we have a negative 1 right here. Negative 1 times 1, so it becomes negative 1 over 25, or if you can put this 25 right here, so it's negative 1 over 25. So this negative 1 over 25 becomes the final answer. Negative 1